It's your boy. It's your boy. Greg in oh no, it's JOSHABRAHAM. I apologize for the wrong. Oh, we're still on Neon Prime. Let me change it. Dude, I fucking hate this. I hate this cough. Cough, cough, whatever. I hate this thing. So this before I go into properties of gas, I think that's properties of gas, liquid, and solid. So before I go into that, I need to first summarize the whole chemical bond, and it's not looking easy. It's not looking easy. I'll tell you that. I tell you that. Oh, shut the fuck up. So we start with the so chemical bond are of three types: ionic, covalent, and metallic. With the ionic bond, where complete transfer of electron goes on, and the form of ion interaction. That's more ionic bond. Covalent bond is a sharing of electrons. There is no complete ionic or complete covalent bond. I mean, there is no such thing as a pure ionic bond. There's never a complete transfer of electrons, right? Mm-hmm. That's electronegativity, Lewis structure formula, a lot of shit. My nose is fucking. He's fucking. That is not 5 minutes. Where's the ChatGPT? Intro to general chemistry. I need to set a timer. But fucking hate this throat infection. What? One loss. YouTube, I'm gonna mute for just a minute. Uh, I don't know why. Am I feeling bad because I want to study? Like, it's just so. Ugh. What do I do right now? I don't even have enough money to buy coffee at this point. To apply for jobs, yeah, I gotta do that. Two atoms or ions are held together by a chemical bond. Chemical bonds are regarded as. You know what? A Wix could change a little bit. I think I could move my keyboard. The whole table is so messed up. It's full. Two atoms or ions are held together by chemical bond. Chemical bonds are regarded as strong interaction between the atoms in establishing a bond, so-called valence. Electrons play an important role. Valence electrons are found in the outermost shell and is often not fully occupied orbitals. A graphic representation of molecules with respect to their valence electron is given by the so-called Lewis structure formula. One reason why a chemical bond is established lies in the so-called octet rule. Uh, um, in strict sense applies to the elements of the second period and halogenides. Thereby, atoms tend to lose, gain, or share electrons till they are surrounded by 8 valence electrons. So they try to obtain current electron configuration of the noble gases with fully occupied orbitals in the outer shell. 6, 7, 8. Okay. P orbital, S orbital. There are three types of strong chemical bonds. Ionic bond, mostly resulting in interaction of metals with nonmetals. The bond is based on the attraction of ions with opposite charges. Covalent bond, electrons are shared between the two atoms. Metallic bond, here electrons are shared between many atoms. Electronegativity, according to Pauling. Electronegativity describes the tendency of an atom to attract the shared pair of electron. Tendency of an atom to attract the shared pair of electrons. Okay. Electronegativity describes the tendency of an atom to attract a shared pair of electrons towards itself. Ionic bond. Ionic bond are formed between elements with low ionization energy, mostly metals, located. Elements with low ionization energy, mostly metals, located on the left side of the periodic table, and elements with high electron affinity, mostly nonmetals, located on the right side. So the for the formation of ionic bond, the difference in electronegativity between the bonding partners should exceed the value of 2. Don't fucking cough. Cough, cough. What the fuck? Uh, uh, um. So there should be an electronegativity difference of 2. The ionic bond usually happens between uh, an atom with high electron affinity and between an electron between an element of high electronegativity. Elements with low ionization energy and high electron affinity. Low ionization energy, where it's easier for them to lose an electron, and high electron affinity, and elements where it's easier to give in an electron or accept an electron. Upon formation of the bond, the cation is formed from the metal, where anion is formed on the non-metal part. Sodium, chlorine. Sodium, half Cl2, NaCl. Half a chlorine, NaCl, delta HF. Stop drifting away. Focus. Focus. Sodium plus chlorine gas gives sodium chloride. So it releases energy. Electron transfer. Okay, this is an example of ionic bond. Formation of ionic bond requires several exothermic. So at this point, the reaction between would require energy. For we would talk about the endothermic reaction. This would be contradictory to the observations we make when mixing chlorine gas with the solid sodium, as we observe the emission of heat. But the consideration made so far relate to sodium and chlorine ions, which are far apart from each other, which is not the case in the NaCl formed. The ionic bond. The formation of the solid array or lattice involves the so-called lattice energy, leading to an overall exothermic reaction as depicted in slide 94. Hey Siri, set a timer for 30 minutes. How would you hear that? Leading to an overall exothermic reaction as depicted in slide 94. The ionic bond properties of the ionic substance: crystalline, high melting point and boiling point. Okay. As attractive forces are stronger in ionic structures than for molecular ones, electrically conducting in melt or solution, hard and brittle. Why were they hard and brittle? A shear stress is applied into an ionic crystal. The planes of atoms slide in response to structure repulsion. Interaction between the ions can lead to separation of the layers. Each sodium and chlorine is surrounded by. Fucking hate this, bro. I hate this. I hate the cough. Cough. Salt dissociate in solution. Salts dissociate in solution. The covalent bond. Non-metals do not like to donate electrons, so the way to achieve the noble gas configuration is via sharing the electron pairs. It's commonly written as covalent bonding cannot only occur between the same atoms showing identical electronegativity, but also between different atoms, such as covalent bonding. In a covalent electron molecule, the electrons of the binding electron pair are equally distributed between the atoms. Electrons of the binding electron pair are equally distributed between the atoms in. Now, distorted ionic bond. In compounds composed of two different elements of the electrons that are not equally shared due to the different electronegativities, a polar covalent bond results where participating atoms are carrying partial charges. The covalent bond has partial ionic character. The transition from non-polar covalent bond to polar covalent bond is to finally ionic bond is gradual and depends on the difference in electronegativity of the present atoms. The atoms of polar covalent bonds form an electric dipole. Atoms of polar covalent bonds form an electric dipole. The molecule has the dipole momentum, for example HCl, where the additional negative charge of around 23% of the chlorine atom and a comparable positive charge on the H atom. So we got ionic bond, we got polar covalent bond, which has partial ionic characters, and then we got covalent bond. The covalent bond dipole momentum. Each polar bond also leads to the formation of dipole, whereby the dipole momentum depends on the magnitude and distance between the partial charges. But as dipole moments are vector quantities, like titties. That was so bad. They have both magnitude and direction. Each polar bond also leads to a formation of dipole, whereby the dipole momentum depends on the magnitude and distance between the partial charges. Each polar bond also lead to the formation of a dipole, whereby but as dipole moments are vector quantities, they both have magnitude and direction. Low electron density at the center of the high electron density at the end of the oxygen. It's where I think the lone pairs. Yeah. H2O. Oxygen atom having the electrons from. Mhm. Lewis structural formulas. Chemical structural formula. Describe the structure of a molecule by depicting the atoms and valence electrons. Does not provide actual three-dimensional structure for. Stop reading just for the sake of reading. Chemical structure formula. Describe the structure of the molecule by depicting the atoms and valence electron. Okay, that's the Lewis structure formula. Sum the valence electrons from all the atoms taking into account over sum the valence electrons from all atoms taking into account overall charge. Use the periodic table to help you determine the number of bright of symbols for the atoms, showing the atoms which attach to which, connect them with a single bond, a line representing two electrons, complete the octet around all the atoms bonded to the central atom. Place any remaining electrons on the central atom, even if doing so results in more than an octet of electrons around them. If there are not enough electrons to give to the central atom, an octet, try multiple bonds. In seconds, the formal charges need to be determined and minimized. How to calculate the formal charges of an atom in Lewis structure? All unshared electrons are assigned to the atom which they are found for any bond, single, double, or triple. Half of the bonding electrons are assigned to each atom in the bond. The formal charge of each electron, each atom is calculated by subtracting the number of electrons assigned to the atom from number of valence electrons in the neutral state. How to identify the dominant Lewis structure? The dominant Lewis structure is generally the one in which the atoms bear formal charges closest to zero. Okay. Lewis structure in which any negative charge reside on more electronegative atom is generally more dominant than one that has negative charge on the less electronegative atoms. Lewis structural formulas. Example for drawing Lewis formulas PCl3. Determine number of the valence electrons. Write down the atoms, connect them via single bond. Complete the octet with non-central atoms. Place the remaining electrons in the central atom. Determine the formal charges. Try to minimize formal charges. Lewis structural formulas. Examples for drawing Lewis formulas. Lewis structure formula. Example for drawing Lewis formulas. Determine the number of valence electrons, write down the atoms and connect them via single bond. Complete the octet for non-central atoms. Place the remaining electrons in the central atom. Lewis structure formulas. Examples for drawing Lewis formulas. Lewis structural formula example PO43 minus. Lewis structural formulas deviation from the octet rule. Hypervalence more than an octet of hypervalence, particularly for elements of the below third period of the periodic table elements. Less than an octet of valence electrons. What kind of music are these? Dun, 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 dun. Your average Sans fan. Hey yo, what's up? How you doing? I'm guessing I saw your comment a bit late, but how you doing, man? As can be seen from the examples, there is more than one probable structural formula. Resonance structures. Resonance structures. Your average Sans fan, I also gotta say, you did give me a game as a gift through Steam. Was that you? That was you, right? I do remember. It was Pal World. Yeah, I appreciate that, bro. I mean, don't tell me you paid for it, because I don't think you should. You're in a stage to pay for stuff. No way. Okay, you did it. Did you pay for it? Like, did you take your real money to give me that? Because I don't think that's good, bro. I did. Bro, come on. Yeah. I don't think you are in a position to earn money, at least from what I know. I mean, it's your decision, but you know, covalent bonding, orbital overlap, H2 molecule, valence bond theory, overlap of two orbitals enables two electrons with anti-parallel spin to share the room between nuclei and form covalent bond. Okay. Bond employing. So I need to look into Lewis structure, then the orbital overlap, the valence bond theory. Hybrid orbitals, yes. Hybridization. sp3, that's the highest. Covalent bonding, multiple bonds. Covalent bonding, multiple bonds. Single bond, triple bond. Do you usually play this game, Pal World? I heard of it. I never played the game. Pal World. I don't even know if Sense is on the stream right now. But you know what? I do want to see what this thing is. Show less. Ten out of 10. Okay. Is it like a Pokemon? Oh shit. It's kind of like Pokemon, but it's an open world. Is Pal World open world game? It's an open world multiplayer. Okay. That's cool. But I appreciate that, bro. But gotta say, I'm still not sure how you get the money to do that. Especially giving money to a random stranger on internet. Electron density perpendicular to the axis between the two nuclei acts as a bond, lies in nodal plane, cannot be rotated. Combination of two p orbitals. Okay, covalent bonding, delocalized bonds. Nitrate anion can be described with the following resonance structure. Upon combination of n atomic orbitals and molecular orbitals are formed. Example H2, 2 1s atomic orbitals give two molecular orbitals, one bond. So, how do I start explaining all these? So, chemical bond is interaction of atoms. It's chemical bond is basically how two atoms interact with each other to stay together. Chemical bond is the interaction between two atoms. Therefore, helium does not exist. Molecular orbitals. I hate this cough. What can I do to improve my situation? Covalent bonding, polar pi bonds and nonpolar. The polarity comes up uh, when electronegativity comes up. Electronegative, yeah. Metallic bond, valence electrons are only weakly bound and can be therefore easily removed. Formation of lattice or positively charged metal ions. Total charge of all electrons equals to the total charge of all positively charged metal ion. Electrons forms an electron cloud, can move freely, cannot be assigned to a single atom, are evenly distributed within the lattice, held within the metal by electrostatic attraction. Atomic orbitals form molecular orbitals. Number of molecular orbitals equals number of atomic orbitals. Energy difference between molecular orbitals decrease with increasing number of atoms. Formation of energy bands. Energy bands overlap partially. Bonding and anti-bonding molecular orbitals when filled with electrons increase. Bonding is increased. So number of atoms increased results in more bonding orbitals and anti-bonding orbitals, but as a result of more bonding orbitals, uh, the anti-bonding orbitals keeps on being free. Mhm. Metals are deformable, electrically conducting. Dotted line separates filled molecular orbitals from empty molecular orbitals. Okay. Okay, so I need to explain it to ChatGPT before I do the explanation. Just a minute. Kung Fu Panda. I'm wasting time, but just a minute. We have to make this difference. No. What did you even do, bro? Yo, your average Sans fan. It was Christmas money, like a gift card. Okay. I mean, hey, I appreciate that you gave me a game from your Christmas money. I respect that, but yeah, it's your decision. Respect your average Saints fan. Respect that. Oh man, this cough. I hate this. Mm. If you're wondering what I'm doing right now, um, I know it's not related to studies, but I was changing my. When you go to my YouTube channel, there's a there's a type of banner image at the top of the channel, and it's blank right now. And I'm thinking of changing it. I'm thinking of adding a text onto that blank banner. Oh, come on. We can play together. Oh shit. Do you usually play this game? Like, I'm also into playing the game. I need to get into gaming. I need to figure out my job, and I just need to pass some exams, you know? Okay, it's too big. Fucking hell, mate. It's too big. 120. Let's see, 120. Okay, that looks really small. Yeah. Cancel. Change. What? Okay, the text is there. I mean, if you're wondering what I did, I could show you. This is how my channel looks right now. Oh, come on! I got this text here. I know, it's a waste of time. 356 hours. Man, 365? That's crazy. What's my highest? My highest would be 90 or something. 365, that's crazy. I need to look into the game. But just right now, studies. Because I'm not studying properly. Okay, that's done. So is there any levels to the game or... Okay. Chemical bond is basically the interaction between two atoms or molecules, how they keep these together to form a stable, less energy form. There are mainly three types of bonds: ionic, covalent, and metallic bond. Metallic bond is more similar to ionic than covalent. Ionic bond is basically based on polarity between two atoms in which It's like Pokemon and Ark Survival. I haven't played both of those games, but I like the gameplay. I saw some images, and it looked. Oh, I deleted it, but it looked like an open world game. Yep, it works, and it's a multiplayer, right? So I really want to play the game, but I will play the game right after I figure some basic stuff. Okay, I'll let you. I don't know if it's too much for you, but I need to figure out. You can give buff Pikachu miniguns. That's crazy. We got buff Pikachu. Yeah, like I said, I just need to figure out a a source of income, and I would like that source of income to be something that is related to what I learn. And I just need to figure out some of the exams, just some of the exams. Like this exam, I have few exams this semester, but that's still doable. I need to figure out the job. That's the main thing. The job. I'm not in a position to play games because no jobs right now. Two atoms. Polarity. Don't tell me. The combat in this game is like turn based, or is it turn based? I don't think so. So based on polarity, in which um, donates the electron to the non-metal atom. Ionic bond usually happens between an element of low ionization energy metal affinity non-metal, and also the electronegativity difference between the elements should be about 2. Mhm. So also there is no such thing as purely ionic compound, because there is never a fully transfer of electron. Rather, in ionic bonds, the electron shift is kinda noticeable. Example, NaCl, NaCl, that's one example. Now covalent. This is where the bond is formed by sharing of electrons, and not all, but some elements, like from period noble gases, kind of follows a rule called octet rule, where I think I should stop bringing my right hand to the left side of the keyboard. I need to just, okay. It's called octet rule, where they where both the atoms try to gain 8 electrons on their valence shell, and basically the chance to share electrons. Now, I'm confused on the Lewis structure, the molecular orbital theory, and the hybridized orbitals. So where do I start? Covalent bond is let me get some hot water. Who told you we can be happy? What is that? I don't know. No, why did you stop playing the music, gang? So, sharing of electrons, that's ionic covalent bond. What else? What else? There's more to it. There's more to it. There's more to it. Uh, there are two main ways to represent the sharing of electrons. It's mainly the Lewis structure based on the VSEPR. VSEPR. Yes. VSPER. Oh, I forgot. There's the which explains the hybridized orbitals, etc. Now, oh fuck, come on. Think. They both explain different uh MO explains the overlap of orbitals across two atoms. The Lewis shows. I don't remember what exactly. Now, covalent dipole moment. We could call it dipole moment, where the atom having more electronegativity could pull in the electron cloud, resulting in the polarity. It's the same as the ionic bonds, but less extreme here. Deviation from octet rule, hypervalid when octet of an electron. There are mainly SP, SP2, SP3, three types. Hybridized orbitals sp, sp2, where sp is the overlap of the s orbital with one of the free suborbital in p. The sp2 is the overlap of s and two unfilled suborbital in p orbital, while the same goes for sp3, where the overlap is between the s and 3 sub of p orbital, resulting in 4 hybridized sp2 results in 3 hybridized hybrid, and sp gives 2 Is there anything else? Oh, shape. It's 2 lobes, tetrahedral, and octahedral. I need to learn the examples. The initial the sigma bond, which is the strongest bond on the basis single bond, then pi valence orbital starts filling in, results in the pi bond which results in the change from single to double or triple based on how much of the pi orbital is filled in. The sigma bond results in the electron density across the axis between two atomic nucleus. The pi bond, which helps in rotation along the axis, while the pi bond what am I writing? Well, the pi bond, the electron density is perpendicular to the plane of sigma bond, and this pi bond overlap results in the lack of rotation that when it was just on the sigma bond. Now, if the atom has more electrons to fill in, then comes the anti-bonding orbitals, which is more energy required to fill in, and if the anti-orbitals are equally filled in like the bonding orbital, it results in no bond formation, as anti-bonding orbitals results in destructive interference, which causes a node on electron density between the atoms, thus no bond being formed, while the bonding orbitals result in the formation results in constructive interference. Always triple bond is stronger than single bond. Is there anything? Oh, if I keep looking at the notes, then what's mean? On the same reason, when one element involved is having higher electronegativity compared to the next one. Resulting in higher electronegativity compared to the other, resulting in what? Then the last one, metallic bond. No, the last type. Let me I'm gonna mute for just a minute. Okay, we are back. No, the player and pal can attack at the same time. So don't get me wrong. Is the latency that bad? Cause I don't know if I seen that. I feel like I asked the question bit too long time ago. Oh, what was that? Okay, it's not a uh turn-based. That's good. Cause I'm not a big fan of turn-based. It's just not for me. Whacker reaction and what is this? We learn how to make linear and aldehydes through hydroformylation, but the smallest aldehyde that can be produced this way is propanal. What about the acetaldehyde? What is produced through the Wacker reaction? Let's learn about this process. Okay. I need to close PyCharm because I think that takes a lot of space or RAM might. Where did I stop? Last type of metallic bond. How do I explain it? This type bond is between number of metal atoms. It's mostly the same of the same element. Of instead of sharing electrons across it's sharing the electrons across the whole lattice. Here, as it's shared across the whole lattice, something similar to the hybridization seen in covalent where orbitals of the same wavelength, like the valence orbital is turned into a band. across the whole. It's something like a common valence orbital, and there's another to the valence band with for more excess electrons. It's called the conduction band. This band is usually the unfilled band, which is what ultimately makes metals metals conductive. Let me drink some hot water. Metals conductive. Makes metal conductive. Come on. Could push the electrons to jump to a higher orbital. Higher band. There's space. God, that's fucking. There's space for electrons to move freely. Push the electrons to jump to her. I think I should stop talking. Maybe that could make a difference. More balance. In changing the flow of electrons or conductivity. Why a voltage is applied, AP? Why did I explain too much on the voltage? Good effort. Good effort. That's it. You clearly understand many cores, but there are important conceptual errors, mixing of models, and some imprecise statement that will hurt you the exam or educational video. I'll go section by section telling you what is the correct definition of a chemical bond. Chemical bond is basically the interaction between two atoms or molecules, lower energy form. Correct, you can tighten up to a chemical bond as an attractive interaction that lowers the total energy of the system. Yep. Types of bond. You said ionic, covalent, metallics. Correct? Ionic bonds, what you got it right. Low ionization metals, low ionization energy, non-metals, high electron affinity, bond driven by electrostatic attraction. Did I say that? No bond is 100% ionic. Partial covalent character, example NaCl is appropriate. Electronegativity difference should be above 2. This is a rule of thumb, not a law. Some ionic compounds form with smaller differences, and some covalent exist with larger ones. Oh, so it's like usually. Better phrasing: large electronegativity difference favors ionic character. Covalent bond. That's where I'm getting wrong. Correct points: sharing electrons, valence electrons are involved. Polarity exists in covalent bonds. Not all covalent bonds are non-polar. Problems. Lewis structure is based on VSEPR. This is wrong. Lewis structure shows electron pairs bonding plus lone pairs. VSEPR uses Lewis structure to predict shape. They are related but not the same thing. So Lewis structure shows electron pairs. Yeah, the lone pair, bonding plus lone pair. Molecular orbital theory explains hybridized orbitals. This is a major mistake. Hybridization, valence bond theory. Oh, molecular orbital theory, delocalized orbitals over the whole molecule. Molecular orbital does not use. This confusion costs marks. Okay. Octet rule, mostly correct, but add octet rule has many exceptions. Expanded octet. Dude, the more I speak, the more I wanna. There's no point in getting angry, right? Yeah. There's no point. Mm-mm. I don't overlap electrons around nuclear and internuclear axis by bonds. I don't overlap electron density above and below the axis. Bibound orbitals start filling. Say bimolecular orbitals form from p orbitals. Electron occupied by bonding. It's too absolute. Talk about it generally. What do you mean generally? Very good understanding here. Thank you, dude. I'm getting good from a fucking chatbot. My professor failed me 4 times. Very good understanding here. Use it correctly. Antibonding equals destructive interference node between nuclei. Equal filling of bonding and antibonding. No bond. This part is solid. Polar pi bonds. Mm-hmm. Block wave function. I don't know about that. Describes an electron in a periodic potential like crystal lattice as a plane wave multiplied by a function that was valence band and conduction band. Mostly correct, but clarify valence band not equals to. Mhm. No, no, don't convert to YouTube script or anything. I'm going for 6.5. Okay. Mm-hmm. Mm-hmm. I don't want AI to glaze me too much. I'll take it. I'll 6.5. I'll take it. Okay, I gotta eat something, bro. We will continue with the sequence analysis after this. Peace out, YouTube. Peace out, YouTube. Dude, I'm so people. I'm still not locking in, but we will lock in. And I don't know what's wrong with the fucking throat or lungs. I'm coughing a lot. I'm coughing a lot.